Welcome to the inaugural episode of Been There, Done That, an original podcast series produced by the Quantum Economic Development Consortium, or QEDC. We're featuring leading voices from among QEDC members in the quantum industry, and I'm Celia Merzbacher, Executive Director of QEDC. Our guest today is Noel Goddard, CEO of Connect, a company that's innovating first-in-class hardware that aims to transform the existing telecom infrastructure into scalable quantum networks. Welcome to the podcast, Noel.
Thanks so much, Celia. It's great to be here.
I'd like to get started by learning a little bit more about Connect. Tell us about the company, what's the nature of its business, and how did it get started?
So Connect, which is basically a play on the word connect, right, is a quantum communications company. We build hardware, so as opposed to a lot of quantum companies which are in the software space, we're purely a hardware play. And I would say that quantum communications, importantly, or quantum networking, is separate from quantum computing and quantum sensing, which are the main verticals in the quantum industry today. So what the Connect actually does is we build a product suite of devices which are similar to what you think of when you think about the digital internet. So you have a series of boxes that are modems and routers and wavelength division multiplexers, et cetera. So those things make the current digital internet work. And what Connect does is to build the analog of those devices for the quantum internet. And for quantum communications and quantum networking, the challenge is that you're trying to communicate with single photons or single particles of light. And in order to do so in a secure way, you're trying to preserve a very special property. You're trying to preserve their quantum state and usually their entanglement. And in order to do that, there's a whole series of new physics and new devices that are trying to come out of the laboratory and into the commercial space to support those types of efforts. And that's basically Connect's mission.
Great. And how did it get started?
So like a lot of quantum companies, it was started by two graduate students and a professor. So that's Mehdi Namazi and Maël Flamand, who are the two graduate students who are now the CSO and CTO respectively. And their advisor, Eden Figueroa, who's a professor at Stony Brook University with a dual appointment with Brookhaven National Lab. And during Mehdi's PhD work, he developed a room temperature quantum memory. So what that means is it is a device which can capture and release photons on demand while preserving their quantum state. And what was so special about this particular device is that it actually worked without the need for cryogenics or vacuum. And this is a very interesting sort of space because a lot of quantum works very well at very cold temperatures or with high vacuum. So to have something that was a more room temperature style quantum device opened up these possibilities of doing things in scalable technology space. And it's always been sort of understood that quantum memories are important not only for computing, but also to build devices like repeaters in the quantum communication space because they set the temporal timing of the quantum network. So Mehdi decided to found Connect basically to be a quantum memory company at the beginning. And that was in late 2017 when he was a graduate student. Maël Flamand, who was a master's student in the same lab, was an expert in physics instrumentation. And during his time in graduate school, he was actually taking the tabletop worth of stuff, which was the quantum memory, and putting it into a rack-style device to try to build the first real rack-style memory unit. And that became the basis for Connect. So I met the company as an investor for a New York State Economic Development Fund. With a physics background, I was really impressed with what they had done and thought this was a really interesting answer to one of the challenges with all quantum tech, which is scalability. And we decided to invest in them and lead their first funding round.
Interesting. So you came in because you believed in the product and the idea of the company. Tell us a little bit more about your background before you joined as CEO at Connect.
So I am a sort of mixed bag research scientist by training. I started off in more of the chemistry space and then drifted more towards chemical physics and then physics. My PhD is from Rockefeller University, which is a known medical institute here in New York City, as a blend of physics and biology. And most of my research career was actually in biophysics. When I did my postdoc I went to Harvard University as part of the Society of Fellows program. And I worked for a few years in Harvard Medical School doing this postdoctoral fellowship. And while I was there, I realized that I really thought that there was a lot to give back to public universities in terms of upping the game for research opportunities in the sciences for students and, again, public universities, state universities, city universities. And I was given the opportunity to build a biophysics program at the City University of New York at their Hunter College campus. So I was a professor for 6 years. Loved every moment of it. I think it's a really important transition in life to actually have the opportunity to see others learn and to be part of that journey. But I was missing research a little bit. And at some point or another, I decided that the right transition would be to jump out and to try to start a startup company in New York based on biophysics, actually. And Stony Brook University had a campus where there was an inexpensive rental to be able to start a lab space. I bought all of my equipment off of eBay, tried to get things off the ground and running. There's actually a food safety diagnostics company using an interesting part of biophysics to test for pathogens in fresh produce. Ultimately, it was not a success, but I learned a tremendous amount about what I didn't know. So I think that's the best thing for entrepreneurs. And while I was out there, I ended up meeting some other businesses and then joining on the leadership team of another company, actually a therapeutics company. And the state knew us because they had invested in both companies. And when the state decided to put together this economic development early stage venture fund, they came to me and asked if I would be part of the deal sourcing and evaluation part of the team. And what I would get in return is the opportunity to learn more about the transaction space for venture funding. So it's a great education. I loved it. And then in the very last year of investing, I met Connect. We led the deal. I was mentoring the founders at the time, and they asked me if I wanted to join the company. So I jumped in and joined the company in January of 2020, just before the pandemic. And we really got to know each other well on Zoom for the next few months as we wrote for basically every federal research grant you could imagine, trying to find ways to keep the company open while the world was in a very unsure place. But it's been a great journey. We grew the company from the first 3 employees to 16 now, which seems crazy.
That's a fascinating sort of path that you followed. I don't think anyone, well, I don't think you probably thought that was going to be the path when you left your education phase and started your career. So I think that's really, sort of a great role model for others to keep in mind. So you have all this experience as an entrepreneur and in different kinds of sectors and companies, and as an investor. So you've been on both sides. What are some of the keys to success as a company is getting started? And you have this experience in the biotech space. What's different about that sector versus quantum from your experience?
It's actually funny. When I started pitching in quantum, I thought how similar biotech and quantum are. So one of the things which is true about the biotech space is that if you're developing a drug, basically you have a small set of potential customers, which are typically pharmaceutical companies who will buy your company. And the most valuable thing about your company is your intellectual property. And I think that's completely analogous to what quantum is today. So most of us who are starting small quantum companies know that the most valuable thing you have in the company is your intellectual property, arguably also your team, but let's just say in terms of assets. And as we look downstream, because of the way quantum has developed, in quantum computing, you've seen that several very large companies like AWS and Honeywell and Google are in that space. Similarly, in quantum communications, AWS is also there, Cisco, Verizon, others. So I think it mimics the same path that small companies are trying to build useful intellectual property and prove that it will be useful to these larger customers, and build towards a downstream goal of either, again, merging with some of these larger entities and or growing and becoming the next Cisco in our case, if that was the way forward.
I want to follow up a little bit on the IP comment, because when you describe the founding, it kind of emerged from a university or government funded environment. So how did the IP get secured at the beginning?
So this is an interesting thing also about quantum. So almost all of quantum starts in universities. It's very unusual for a quantum company to be an independent founding team that does something outside of university research. So most quantum companies have at least one or two legacy patents, which they licensed from a university as sort of their first founding steps. And one of the things I used to say all the time to young founders is that they shouldn't resent the fact that they're licensing something from a university. This is just part of the growing process of being a company. When the company is established, then you start creating your own IP. But it's just part of doing business. So the realities are that the university provided you infrastructure. The university provided you, a stipend and the ability to study and to create these things. So they have certainly contributed, and therefore they should get some part of the win. And it's good for the university, of course, to be associated with success because that betters the student body and increases their chances of continuing to get research grants, et cetera. So I think most quantum companies start off with at least one licensed patent from their university founder lab. And then depending on how the relationship evolves with that university or other entities, you may or may not continue to build your intellectual property portfolio with them. In QNEC's case, we've actually been completely independent ever since the founding patent. That's largely just a sense of by choice. I think the universities have a different mission, which is not only to educate, but also to do very basic research. Sometimes it's not unusual to see a quantum company where they have a long-term relationship with the university because the founders lab continues to produce intellectual property, which the startup company then licenses. That's one way to continue doing it, and the advantage to that is that you basically get the entire team of university researchers that are basically your outsourced R&D doing great things. Or you can choose to try to do it internally. But if you do that, then you need to actually build your R&D team internally, which can be very expensive. At QNECT, we decided to do it because our vision of what we wanted to do was very applied. And that was not the vision of the founding scientist, the senior researcher, who wanted to continue to look at more basic research ideas in the space.
So you mentioned that some companies continue to depend on the university or the sort of origin, the organization from which they emerged for R&D capacity, essentially. I see a lot of small companies that, don't have a lot of capacity to do additional R&D. So is that a risk, and how did QNECT deal with that? And how should others who are migrating or transitioning think about that particular aspect?
It's a great question. I think, again, this is another place where it emulates sort of the biotech space. It's unusual to meet a company which is working on a therapeutic that has not developed a fair amount of their R&D through federal research grants. And I think when you meet companies in the quantum space, younger companies today, who are trying to build hardware especially, you will find that many of them need to rely on federal research grants in order to get out of the gate, basically. QNECT certainly did that. So we spent the first sort of 3 years of our company from the end of 2019 until now, basically running off of federal research grants to help us develop the hardware and the instruments which we now have commercialized. They're the small business initiatives, so the SBIRs, STTR programs through the Department of Energy and the Department of Defense have been very generous to the quantum industry in general, so it's a good place to start with these things. The problem is the time scale. So in both the SBIR programs and STTR programs, you have to go through phase 1 to get to phase 2. Those things have their own review cycle, award cycle, et cetera. And typically the first money is quite small. So depending on the grant that you receive, it may be between 150,000 and 250,000 for phase 1. And then the phase 2 can be 1 million to 1.5 million. That's obviously lucrative and allows you to do a lot of things, but you have to wait out the time to get there. So the way we did it is that we decided that we would first start off with a very small team in a very focused way, working on our most advanced instrument, even though we had a larger product suite. And that as we received more grants, we would offset the salaries of hiring new scientists in those grants because you can use that for direct costs. And that we would use that primarily to buy expensive equipment and to hire new people. And we did that for, again, the first 2.5 years of our existence, which allowed us to grow the team. And I think when you're asking about risk thing, the one thing that we always kept in mind was where are we going? What are we doing all this for? Because it's something that happens a lot in startup companies is that you have a solution that doesn't have a problem. So they'll always say, like a solution looking for a problem. You don't want to be that company that doesn't have any market to feed. So very early on, I started to talk to downstream investors that were not ready to invest in QNect, but ask the question, if I wanted to get your attention, where would QNect need to be in terms of the technology advancement? What would you like to see in order to start having a real conversation? And we always had in our mind that goal, which what I would hear over and over and over again is, you have a product suite that's a lot of instruments, a lot of technical risk, a lot of scientific risk. For downstream investors, they want to see some of that risk go away. So one way to do that is federal research grants in order to do your R&D and de-risk the scientific side of things. And then the other way to do it is to sort of like plow forward with some angel money, some other early stage money, and say, I want to take this from basic research into a prototype, and then show that your prototype can do something. So what downstream investors are telling us is that we would like to see the majority of your product suite de-risked by becoming prototypes before we have a serious conversation. So we always had that as a long-term goal, and we kept looking for grant opportunities in order to fulfill that goal. And whenever we would raise money that were small rounds at the beginning, mostly convertible debt, we would do the same thing, right? So it was all with this idea of we need to get to this place in order to engage an investor in a serious way.
That sounds like a really good pro tip. And that is talking to potentially future investors before you're actually fundraising. And I guess I'm surprised in a way, since you were an investor in one of your previous roles. But is that common, or is that advice that most people hear? I think I really want to sort of shine a light on that, because for those who are thinking about when to start talking to investors, it sounds like the earlier the better in some ways.
But make sure you have the right conversation. So that is true. I think the biggest mistake small companies make is that they pitch a serious downstream investor too early and have this expectation and disappointment that happens in the conversation because the company doesn't understand what makes the investment fund successful or tick, right? So each investment fund has its own way of making money, and you need to understand what that investment fund does. So for instance, there are a lot of great deep tech early stage investment funds. The vast majority invest in things which are not as hard as quantum technology. So if you look at their portfolio online and they do not have any other quantum investments, the chances that they're going to be super excited about your quantum technology may not be where they're really looking to make money. I think that for quantum technologies in general, it's good to look at frontier tech investors. These are investment funds which allow for a longer investment realization and return on investment. So the old school, sort of more standard VCs in the tech space have a 5-year ROI. The more forward-leaning or frontier tech type leaning ones have a 10-year. So with those companies, you can have those with those funds, you can have conversations earlier because you can have this and say, this is my long-term vision. This is the path that I'm going to march in order to try to get to that vision. When would be the right time that we could actually think about having a good conversation and engaging? It's okay to admit to the investor, in fact, you'll get some sort of street cred for it, that you understand that maybe today is not the day that they're going to write a check. But it's very important to say, where do I need to be in order to re-engage? And I think that that's true for anytime any small company pitches a fund and the fund says no. There's a lot of easy ways for the fund to say no, and just a sort of triage way. but there's nothing wrong with the company saying why. So I think there's something good about asking, well, why didn't you invest? Now, if it's just not the model for the fund, nothing you can do about that. But occasionally you'll get some real nuggets about things that you didn't think were true. That was the impression that you made on the investor, and it can be very helpful in future downstream pitching.
Yeah, and because things are so early, I think that they're learning at the same time that the people who are developing the technology are learning. That gets a little bit to this idea of the market, figuring out what the market is. These markets are largely still in the future. So how did Kinect think about markets and what the demand might be and that timeline for kind of cultivating the market at the same time that you're developing the technology?
So the problem with pitching a investor who wants to have a beautiful hockey stick market graph in your deck is that by and large it's very difficult to collect those numbers for quantum technology right now. You can buy some of these reports. There's always marketing groups that are creating research reports even in the quantum space, but it's not incredibly clear where those numbers come from and whether it's something that you as a company can really put your trust in. I think what our strategy was when we started off was to say, these are the challenges in the field. If we would like for this to grow as a truly scalable technology, we will show you how we meet those challenges in the field. And by meeting them, we hope to be a company which produces a suite of products which we can give to researchers who can then start being the early adopters. And as early adopters, they can then flesh out protocols and other things that need to be done for quantum communications. So our goal had always been to basically define what early adopters had as a barrier to adopting, make sure that we were creating something that was going to be adoptable, and then use that as saying we understand our go-to-market, we understand the long-term vision is if these products work, we have addressed these challenges that would be downstream challenges to scaling. And if the world is going to do this, these are the sectors, and we would name off the sectors. So in our case, for quantum communications, I think the first basic bin that you will see in terms of this influencing the world will be secure communications. So it's slow compared to digital communications, therefore things which are security sensitive as versus bandwidth and data rate and other things which are typically drivers in telecom. That's not the case for quantum communications where security is key. So what are the industries which could benefit from security? And then explain, I know who the industry customers are. I know what the barrier to my first adopters will be. This is how we're trying to meet those challenges. And then this is how we're looking further downstream to meet what we perceive to be future challenges as we grow into the industry. So it's like meeting the question by coming through all sides of it.
So when you say security, my mind goes to government customers, and I'm sure they are one category, but also perhaps people who are dealing with medical information or financial information. So are you talking to all of those end users at the same time? The government seems like maybe the one that's likely to continue to fund the R&D to get us to that future. Do you spend much time talking to those ultimate users?
We do. I think one of the challenges which you alluded to earlier is the fact that the market is so early that nothing has been well defined. And again, if you want somebody like a Verizon or an AT&T to adopt your technology, the chances they're going to do it when there's not a standard in place that says all quantum networks should run on this standard and everybody should engineer to meet this standard. So trying to get them to adopt before that happens is sort of a little dreamy. However, I think that it's still important to have the conversations with all of those downstream users. So I'll do a little plug for the QEDC because one of the reasons we joined in the early days were to actually have the conversations with the people representing industries from those types of organizations. If you decide that you want to talk to the quantum rep from Verizon today, how are you going to find them? So joining an industry organization is a great way to do this. We joined some of the technical advisory committees in the early days so that we were on a first name basis with many of these people that represented different parts of the industry that were in it, I would say, those industries are more in a browse forward mode. They're looking for what could be developed downstream and trying to keep on top of the technology through a more scouting program. For the finance industry, we're sort of blessed that we sit in New York City. There are a lot of quantum tech groups in the financial institutions within New York City. So they come and see our tech. We have conversations with them about their wish lists. And then we start to think about are there ways that our groups can collaborate together. On the government side, it's typically, I think, to some extent, clearer how things evolve, because if the Department of Defense wants something, they put a very clear metric that they want people to hit. And that may come out as a grant opportunity, that might come out as a competitive government contract. Those are things where you can have a little bit more specific feedback of what it is that you would like to develop. I will say that every company needs to get a product out there to learn what's wrong with it. So when QNect started producing, commercial instruments, which was the end of 2021 when we sold our first quantum memory, we had no idea the types of problems that we would have, the feedback that we were getting. And it's a great way to start to, again, have these conversations about how would you actually use these instruments.
Yeah, I think there's nothing like actually having a customer who can tell you,
Break it.
how is it going? I'd like to pivot just here for a few minutes and talk about the importance of the team. You mentioned that you've grown now to around 16 team members, and I'm curious what the strategy has been to identify the right people and think about that growth phase as it's happening.
So I think this is a little bit of a layover from being a professor. I've always taken it very seriously whenever you bring a new team member on board into your research organization, because in order for them to be at their best creativity, they can't be scared of losing their job. So I think there's a great responsibility you have as you're starting your company, that somehow you need to incentivize the early team members to understand that they're part of a community that has this great opportunity to do something creative and amazing. And the strategy we always followed at QNect is that we understood that it wasn't the same as working at some of the larger companies, which are much better funded. But you have this great opportunity, and that we all are in it together, and our salaries are proportionate. I think that small teams need to recognize that it's like being a small family. Everybody kind of knows everything about everyone else because you're working in this very intense way all the time. So thinking a lot about equality in the group and motivation is a good way to think about early management strategies. We knew from the beginning that we really needed to hire more researchers. We couldn't offer competitive salaries because we were paying for them off of our first research grants, compared to some of the larger companies that were out there hiring quantum physicists. But what we could do is we could say, if you want to work on this topic with a lot of freedom to create, we can offer that environment, and we can compensate you in other ways like equity and other things in order to join our team. And I think we were very fortunate in the early days that everybody who came on was basically a believer in the vision. Some people will say it's sometimes nice to not have very high salaries because you know that people join because they're really interested in the work more than they are the salary. I think there is a little bit to that. It's hard in the quantum space to build teams because right now it's more competitive than it's ever been for talent. As some of the quantum companies SPACed, they scaled their workforce by dozens of quantum physicists, which meant that the output in the United States, right, was completely consumed by all of these companies. At the same time, I think, there are different ways of running companies. We are a small company, so we tend to run very much like an academic lab that produces products and now has a manufacturing division. For larger companies, there's a little bit more job security. It runs a little bit more in a structured way where there's sort of very defined reporting roles and hierarchy and other things. Most small quantum companies start out like us. They are basically coming out of an academic research sort of group where everybody has this expectation that you need to work towards milestones, not towards 9 to 5. And those milestones are going to be important. They should actually benefit the entire team. Everybody's success is shared. And we were lucky in the early days that the people that we hired were on board with us for that. We've shared our successes with them. Every time the company managed to get Another major research grant, we raised salaries across the entire team to try to bring them up. And now QNect is, it's New York City, so I wouldn't say that we're competitive, but we're definitely on the lower edge of competitive salaries for all of our team members. We, oddly enough, do not have any business team. So one of the things which changed with the way that we built out the company is that since we built through federal research grants at the beginning, it was very easy to hire scientists, engineers, and programmers because they could be supported on these grants, which would run 2 years. But it wasn't so simple to hire the business side. So we built that out first. It was obviously a priority of the company anyway. I want to emphasize to every little quantum company which is out there, do not ignore the business side. So that's always one error that high-tech companies make. You need somebody who's thinking about the business piece. You need lawyers, you need accountants, you need all of these things which are expensive and not something you understand typically as you're coming out of academia. So you need that. But one of the interesting things right now is that between software programs, platforms for spend management, et cetera, and accounting and outsourced talent in those fields, you can very often assemble your business team as a collection of outsourced experts that help you at whatever level you need until you have the need to hire a full-time person.
Yeah, that's great advice. And QEDC is trying to also help all of the smaller members not have to maybe figure everything out alone, which is part of what this series is about. I'd like to maybe wrap up by getting your vision for the future. Where do you see QNect and the quantum industry, or maybe the networking and communications part of quantum, in 5 years or 10 years from now?
So one of the things that I was really excited about when I saw this, and something that made me confident about changing from biophysics into quantum physics, was that I felt like QNect had a solution that met a true market need. So one challenge which is absolutely there for quantum networking is that if we want to build an infrastructure at scale, we have to figure out how to get away from cryogenics and high vacuum because it's just too expensive, cannot be put every 25 kilometers. It's just the way it is, high maintenance, et cetera. So I'm super excited that I thought it was going to be one of the first quantum technologies that average people across the globe were going to have much more of an interface with, particularly if quantum networking, quantum communications, quantum secure networking, et cetera, if this ends up being something that starts to protect all of our financial transactions, it's not something we realize is there, but it's something we all need. Our entire world is about doing e-commerce and financial transactions online. And as we're more and more worried about the cybersecurity aspect of this, having some physical way to make these things robust and secure is in everybody's best interest, right? And then as we saw with the normal internet, so with the digital internet, we saw there was no way to even imagine the types of applications that came out of the early days of being able to make ARPANET run, right? I'm sure that they could have never thought that we were even streaming Netflix over our phones, right? So who knows what the ultimate great use of quantum networking will be, because I think those things will be revealed downstream. But I think a very near-term, powerful impact statement for quantum networking in the next 5 to 10 years will be to secure financial transactions, critical infrastructure transactions, data storage, the things which are important to all of us, even if we don't know, even if we don't see them, right, in our normal everyday lives, they're behind it and they make our worlds, right, much better.
Yeah, I think you're absolutely right. There's a lot of cost to cybersecurity weaknesses today that the consumer probably doesn't even realize. And so I'm sure that layer, the financial institutions and others who are bearing a lot of those costs are going to be quick to adopt as this technology comes along. So we'll all be really excited. We'll all benefit in ways, as you said, that some of us will never really even be aware of, and in others that I'm sure we will. So I want to thank you, Noelle, for being our first interviewee on this program. And thanks to everyone for listening to the inaugural episode of Been There, Done That. We hope you'll join us each month as we continue our conversation with leading voices from among QEDC members, those who are inventing and creating the quantum industry. Be sure to subscribe to our podcast on Apple, Spotify, Google, or wherever you listen to your favorite podcasts. Thanks for joining us. Take care, and we'll see you next time.
Thank you.